Okay, the other main idea in section 5.5 is Simpsons Rule. And Simpsons Rule is even a better approximation, and rather than using trapezoids, which are straight lines up at the top of the curve, we use kind of parabolic curves. Now, I'm not going to go through all the exploration, but they do have this. I'll show you this in the book, and this is pretty cool. I've gone through this before, and you can work through this exploration, and you can actually see how they actually prove that you can find the area under a parabolic curve by this formula. All right? And this basically is the whole basis for the Simpsons rule. Rather than using trapezoids, we're using curves up at the top to approximate our area. And you can see right down here, this is Simpsons rule. And I'm just going to restate it and give you an example. And I just use the same example in the book. It's pretty easy. You just have to kind of remember that instead of h over 2 in the trapezoidal rule, you have h over 3. And instead of all these 2's in the middle, because we still have y0 and yn at the ends, instead of all these 2's, we have to alternate 4, 2, 4, 2. And the key thing is we also have to have an even number of subintervals. So let's just kind of go over that real quick. This is Simpson's rule to approximate. And this is what we just showed you. This was in the book on page 309. H over 3, and then we just have to alternate these, 4 and 2's. And A, B, that's my interval. It's got to be partitioned into an even number of n, or an even number n subintervals of equal length. So n must be even. And H again is the same as in the trapezoidal rule. H equals, or the length of the each subinterval is b minus a over n. So they do have to be, again, a uniform subintervals or subintervals of equal length. So here was an example, and this is basically the one they do in the book, so I'll just go talk you through it. Then you should have any trouble doing the work, and I will go over this for you, but it's just a lot of arithmetic sometimes. So anyway, n equals 4. We're going to take the interval from 0 to 2 of 5x to the fourth. So first of all, I determine h, and n is 4. So it's going to be, this is going to be my AB, so this will be my b minus a all over 4n, which is 1/2. And this is basically the Simpsons rule I'm going to use for n subintervals. So I'm going to have h over 3, y sub 0, 4y1, 2y2, 4y3, and then 1y4. So that's going to be the setup for n equals 4. So I just substitute in the rule. 1/2 divided by 3. Then y sub 0, well, I'm starting at 0, so that is going to be 0, because it's going to be 0 to the 4th times 5 is 0. Then it's going to be 4, this is from my Simpsons rule 4, and then this is from my function 5 times, and then my subintervals, if I think about it, I'm going to go from 0 to 2. So it's going to be 0, 1/2, 1, 3/2, and 2. That's how I'm going to subdivide that. And you could draw a line to maybe help you get that if you want, if that becomes kind of an issue. If you just think about your subinterval from 0, I guess we could do it over here, 0 to 2. And there's 1, there's 1/2, and there's 3/2. So that's how you can divide your subinterval into your 4 little sections there. And that's going to be n equals 4, 1, 2, 3, 4 little subsections. Okay? So you're going to be putting 1/2 in your function, you're going to be putting 1 in your function, you're going to be putting 3/2 in your function, and 2 in your functions. And your function is 5 times x to the 4th. So again, this is going to be 0, so 5 times 0 to the 4th is 0. And then 4 times, and then 5 times 1/2 to the 4th. And then this is the 2, 5 times 1 to the 4th. And this is the 4, and then 5 times 3/2 to the 4th. And finally, just 1 there, so that's just going to be 1, and that's just going to be 5 times 2 to the 4th. So those are where these numbers are coming from, and you're just putting them in your function. And this works out to be 0, and then 1/2 to the 4th is 1/16, so you have 4 times 5/16, 2 times 5, 3 times 3 is 9, times 3 is 27, times 3 is 81, 5 times 81 is 405, and then 2 to the 4th is 16, and then 2 to the 4th is 16 times 5 is 80. And then if you work this out, arithmetically, you and multiply by the 160, you end up with 385 over 12, and you can work that out. Don't really want to spend time doing that. But that's kind of a Simpson's rule in a nutshell, and you get plenty of practice for your homework, and we'll go over those problems. And I'll have those up so you can see how those are done. And once you go through those, you'll be okay. It's not too difficult. And I hope that helps. And I'll try to get this homework up over the next couple of days.